which is abbreviation for safety extra low voltage. The safety extra low voltage in the electricity is standardized by if the voltage range is less than or equal 120 volt DC or 50 volt EC, okay, then it's categorized as a safety extra low voltage, SELV. SELV network or electric network doesn't have to be earthed. This is one of its characteristics, and it just needs some safe installation. So our KNX network, our KNX bus system, is categorized as SELV, safety extra low voltage network, because the voltage of DC is 30 volt DC coming out from the power supply. Okay, so for your network, you don't need insulation from the user, so the user can safely touch the core network without being, let's say, having an accidental electric shock or anything, because it's safe for him. And in case you are putting the SELV network next to main cables or power cables, then you need some kind of insulation, safe insulation. Also against other networks like, let's say, UTP or telecommunication also need safe insulation. From the PE or the earthing, you don't need to earth the SELV network. Fine. The cable of the KNX has two standards. So first, the cable looks like that, by the way. Okay, this green one is a cable, and the cable, as you can see in the graph in here, it has 4 cores. Okay, like that. Here it's connected already, but the cable comes like that, and it comes in reels, of course. So 2 cores, one core is red and black, and the other core is white and yellow, just like what you are seeing here. In here. Okay. Then the cable has the external shielding, the green one, and then another core, and then a plastic shielding, and then the core itself. Okay, so it looks like what you have in the picture in here. The core, the cable of KNX cable comes in 2 variations. One called YCYM, okay, which is suitable for outdoor and when you have humidity or wet areas. The other one is JYST, okay, and it's suitable for indoors. The first one, the YCYM, is also can go via more voltage, okay, but the other one, the indoor one, can go only for 220 volt. We'll come this to the next slide. And then you have the cable, and you can see that the cable has the shielding, and as we said before, it's recognized by its green color. We said in the past slide that you can have the cable insulated from the power cable, the main cables. Actually, the insulation is the insulation coming with the cable itself. So this green one, remember the slide? We said that the SELV network, like the KNX, should be isolated from the main network and from the other networks, okay? What kind of insulation do we have? This is the insulation we are talking about, the green one. So if I have the power cable, the main cable, okay, and the KNX cable, and the KNX cable is insulated, so the whole green shield is still in there, then they can go next to each other. So I don't have a distance. I don't need any distance between the KNX cable and the main cable if it is insulated, okay? And regardless if the power cable is insulated or not. I'm just talking about the KNX cable. So if I have the green part, then they can go next to each other here. I don't need any distance in here. Okay? So our all installation single core 20 to 30 volt advances to the sheets of the bus cable, so they can go without insulation. In case the green one is not insulated, so the insulation is not up to the cores, like here. I'm just going with the core, then I have to put at least 4 millimeter between the KNX core cables and the power cable, the main cables. Okay? Also, regardless if the power cable is insulated or not, I have to put 4 millimeters at least between the both cables, which is also very small, very short distance. Okay? So it's practically, if the green one is there, so the insulation is there, then you can go in the same duct, in the same conduit. If not, then you have to at least put something like 4 millimeter between the two cables. I'm using more than one power supply on the KNX line. How many power supply I can use? If it's a centralized power supply like we're talking about, then maximum power supplies on one line is 2 power supplies. Okay? So it's 1 or 2, that's it. I cannot put 3 or 4 if it's a centralized power supply. And the distance between the 2 power supplies, I need to check with the manufacturer, okay, and find out how long distance I should keep between the power supply number 1 and the power supply number 2. And every power supply will come with a shock. So like here, okay? That's the maximum distance between power supplies as specified by the manufacturer, okay? And they are in the same line. Connector is this one. It looks very big in the picture, I know, but actually it is this one. You see this one? This is the bus connector you have. The bus connectors, as you can see in the picture, it has 2 parts, red part and black part. And in the red part, I insert the red cores, and in the black part, I insert the black cores. Okay, just insert it in here. Like I'm doing that. And then you take the bus connector itself and you insert it in the device itself. So this is the KNX device, okay? And I can just go like that. Like that. Like that. Okay. And I can take the connector itself. So with the connector, the bus cables are going to the connector, and then I can put the connector itself to the KNX device. So this allows me to be able to isolate a KNX device from the network by just pulling out the bus connector. So I don't need to play with the cables or anything. This one thing. I also use it to branch cabling, as you can see that I have here 4 areas in the red one and 4 areas in the black one. So I can arrange that. I expand it like here. I go to one bus connector to the other bus connector, or from here I can use even the bus connector to give me 2 cables together to another bus connector. So I can branch the cables, extend the cables, or connect the cables. Okay, the bus cables will have end with the bus connector, and the bus connector can easily remove from the device itself. And I cannot put it on the other direction, meaning that if I want to put the bus cable here, the bus connector here, I have to put it like that. Okay. If I try to put it the other direction, it will not fit. So there is mechanical protection here using this notch to make sure that I am putting the bus connector in the right direction. So I cannot reverse the polarity. And we'll see this, by the way, in the practical part. I just wanted to show it to you so you know what we're talking about. So this is the bus connector. So this is the one that's making the cables coming to the KNX device. Okay. So we are done now with the connecting the devices. Now we'll go to another part where we are talking about lighting protection. Lighting protection, meaning that, and what should I check after the installation is done? First, I need to check that the permitted cable lengths have been observed. So I have to make sure that the length of the single line segment is less than 1,000 meters, or I'm using repeaters if I want to use or I want to extend to more than 1,000 meters. Okay, need to check visually that I have marked the end of the cables, meaning in the DB itself, I need to make sure that these cables are marked. So I know that this is related to line 1, and I know that line 1 is going to floor 1 as an example from my documentation, this line 2. Okay, and this is for the specific room in line 1. So I need to make sure that the lines are marked in a way to support me and help me later in the project itself. Okay, I need to check the installation for indispensable cable connections to make sure that the cables are strongly connected, not loose. Okay, because loose cable will come with an issue after that. I need to measure the insulation resistance of the bus cables, making sure that the insulation is still in there, and can use this by applying voltage like 250 DC from the core and the earth. Okay, and then it should be insulated. I need to check the polarity of the bus devices, making sure that I did not confuse the positive with the negative and vice versa. How to do that? There is a single program button on each device, like this one. Okay. And when I press the program button, then a LED will light. So I just go to the devices and I press the program button. If the LED gives me a light here, so the device is connected. If not, then the device is not connected, and it might be due to a loop or due to the polarity is reversed. Okay. I need to check and measure the voltage at each bus cable end and make sure that's minimum 21 voltage DC. Okay. I need to record all these test results, and then I put the test results with the ETS file and give it back to the user or the consultant as a closing or part of the documentation of the project itself. We are done now with the installation